Hi there, I'm Kerry Ellis, author of 21st Century Superhuman, and this is our 21st Century Superhuman show. Today we have with us Dave Stewart at Mission Impossible Peru, soon to be Keshe Peru. Dave, how are you today?
Hey, welcome to Peru. Got an exciting show for you today.
Cool, I know, I'm excited to hear what you've got to share with us, and you have Daniel with you there, right? In a growing team. Hey, Daniel.
How are you?
And we have JC Anderson, tech whiz of the Keshe Foundation, who helps a lot with customer support. Or I guess, is it customer support or?
Tech support.
Tech support. Okay. And we love it that we're all here. We've known each other for a long time, and we've all been working together, and it's really nice to have each other to bounce things off of. I'm actually wearing a Triskelion that Dave made down at MIP Peru for my visit last year. So it's really fun to be part of this team and be connected from around the world. And I just want to just invite everyone who's in the middle of learning and growing at the Keshe Tech to tune in, share this with your friends, because we've got some exciting information on just the technical aspects of this. Dave, you used to run big construction projects in the Caribbean, I know, and you have this really great ability to kind of mastermind all these details, and I love that. I just really appreciate it so much. And so we're going to let you jump in and tell us about some things, and then I think we're going to talk about a car unit at some point too, JC.
Yeah, we got some new information, an interesting new twist. There's been some people that have been having issues with their car units, and this may be the fix for it.
Cool. How exciting. All right, Dave, go ahead. Give us some lowdown on what you got going on down there.
Well, we are now recognized as Keshe manufacturer in Peru. We're just going through the process of registering all the people's specific positions. So we've got a marketing manager. We've got administration, English and Spanish. We've got a Hernan coming from. We've got Hernan coming from Costa Rica. He's going to be our operations director, and we're going to be starting to order things in from Keshe once we've formed it. So basically, we've even got now our own letterhead. There she goes.
Wow, that is super cool. Awesome.
So with the Hector in Peru, he's one of our engineers. He designed and built these T-shirts, of course, for Mission Impossible, and we will be having the polo shirts with Keshe Foundation Peru. And what I want to speak a little bit about is I want to speak to you about forming the Keshe Wawa. That's Quechuan for Keshe Kids. So we want to put out for a donation on XI4 so we can pay for tables and chairs for these kids. And, you know, I will be trying to get Rebecca here from Colombia. And Rebecca she's proven herself to be magic at teaching kids. She knows how to teach kids. I don't know how to teach kids. But it's a certain skill that she's got. And she left here a changed woman. She was very good with us. But she's got a little problem coming over the border. She's got a fine to pay of 450 sols or dollars. And then she can come in. So we're expecting her to be approved anytime by the Keshe Foundation to become part of the team. And we will, I'm just looking down here now. So there you are. Our letterhead now is all up and running, and we will soon have the T-shirts and so on and so forth. So that's the exciting news from down here in Peru, Kerry.
So Dave, we'll put the link for your XI4 article under the video, both on the blog post and on YouTube, so that people can look, they can come to your blog, and they can see how they can assist to help you move this project forward in these little ways.
Yeah, and also I'd like to make a point here that Keshe Foundation Peru will be dealing with Peru, and therefore we will be supplying Peru. We've got Hector, who's an excellent marketing manager. He's going to be visiting all the cities, and we've got an opportunity that we might be able to provide many thousands of units for one of the cities where the government are very interested in seeing this technology. We've got it working in the office here right now behind us. Nice. Our machine is literally a bank of switches. We can do a 240 and we can do a 110 volt.
In just a minute, we'll let you and Daniel demonstrate that for us. You did for me a little bit ago. That was really cool. I wanted to say, I know I saw in the chat room a few people saying, well, I'm shopping around for Magrav units, so if you're making them in Peru, can I order one from you? And I think your response, which I thought was really great and should probably be the standard right now, is that you're going to be making them for in the country of Peru. And they're kind of being set up to go with the economies of certain countries and being able to be shared within that region. At the same time, you'd still like people to come there and be building their own, right?
Absolutely. I think with Eduardo and Wan Chan's experience from China coming over to Peru, the hands-on issue, you learn more. You definitely learn more. We need to show what we've got here, all the different types of GANS that we've got, all these things and how to make it. This is important. We've got a nice.
What do you have there, Dave, besides iron GAN, or the iron? Go ahead, tell us what each one is.
Well, we've got silver GAN, that's pure silver GAN.
Beautiful.
Okay, it is beautiful. Now, these three colored ones here, that's the CO2. That's very white, isn't it? Look at that, Kerry.
Nice.
And then we've got CuO. Now, these are having fantastic results. I've got to tell you, and look at the red, beautiful.
Those are gorgeous.
Yeah. So what we've got is, we've got aluminium GANs as well, and we've just made lead GANs. We keep it separate. We've been told to keep it separate from these and keep it away from these because it affects it. Anyway, that's our little GAN setup. We've got lots and lots of this GANS water, and this is the stuff that's healing people's swollen bones or swollen ankles, ear infections. Just the other day, 4 people.
And so how is it doing that, Dave? Are you putting it in the health pads?
We're making health pads, and here are some here. So if we've got blue, that means it should be CuO, red. Stripe should be CuO. And we got the white one with CO2. And these are really having excellent results. And we're just about to start working on people with arthritis that are coming through the door now. So
if somebody paid you a fee to come down there and work with you for a week and learn how to make their own unit, could they make themselves some health pads as well?
You will make everything that we can make here. You will go back with it. You will go back with a working unit because you'll test it here. And you will get, you can make your own cannon. I've got some here to show you, our cannons. Everyone's taste is slightly different, but there's our cannon. That's a big one. We're selling these for
Wow, can you hold that sideways without your hand on it, Dave? And just show us what's in there.
Let me see if I've got it. There's one that's bare naked. We've broken it, but it's a good one to show you.
Good.
What's inside it.
Nice. And so have you got 3 coils in there? Or you've got a center, you've got 2 coils and a center pin?
Center double. A center double right in the middle there, which is the longest end. And then we've got a coil, which is anti-clockwise. And that's in the center over, it fits snug right over the double twisted pin in the center. And then we've got the third one. We drop it in epoxy resin, and then we drop it into the test tube and put epoxy resin on the top. Now,
And so you've nano-coated that as well, right?
no, I didn't nano-coat this one. Now,
Okay.
I'm going to show you our picture. This is our one that when we put it in the bowl of water with, it's got a dye in it. And what happened was it showed the torus field. You can see clearly here that this has got a massive field. So what's happening here is excellent, Kerry. If you look at the torus field, not only have we proven that the torus field is emanating out of that pen that you've just seen, or cannon, whatever you want to call it, a healing device, you also get the secondary, this is where the illness is coming out. We've worked out that this is what's happening to your body when you put this over a guy's wrist who came to the office who said he couldn't move his wrist very much after an accident. We gave him 20 minutes with the health pen over his wrist, and he was amazed that I can move my wrist now. I haven't been able to do this for years.
That is awesome.
Yeah, so we're getting some splendid results from not only the pens, but these coloured bags with the GANS in. And these are really working good. We've got a guy with a prostate problem, and I said to him, how do you know, if you're not a doctor, how do you know that you haven't got a prostate problem now? And he goes, I simply haven't got any pain, and therefore it gives me the confidence that I've got no prostate problem anymore.
Excellent.
So, you know, we're getting some great results down here. And,
what was the heart-shaped thing you were showing me earlier? The heart-shaped field? What is that from?
This is one I picked up off the internet, but it gives us a great idea. This is one of the best pictures I've ever seen. And so I'm sorry about the splodge on it. We've dropped some ink dye on there that we use for the... So if you look carefully at that what I'm saying is that the heart shape, you can see where the cannon is there, and then the heart shape, but look at this stuff that's going on here. This is incredible. And that's your illness coming out of your body when you use these cannons or when you use these bags. Because as it clearly shows on this particular picture here from Keshe, you can see the torus field going right through the body, and that's what's happening. If we can prove, and this is the thing, if we can prove that you can freeze your health pens and find the torus field, every single one will have their own signature, and you work with the one that you think is correct for you. And you know, everyone's different. You can see, sorry, can you see that, Kerry?
Yes.
Can you see right through it? That's very important what's inside there.
And Dave, tell us the thought behind the twisted pin in the middle, or the double.
Well, if I go back to this one, let's go to this one. Okay. Because, let me see, Daniel's got a light here. I don't know if he's come to show right through the end of here, because you wrap that around a nail.
No, it's too bright, Dave. It's too bright.
Okay. Well, and then here's the bare end of it right there, if you can see that. And that's really a laser, intention laser. That's going to read what your intent is, and it's going to, if you want somebody to have good health, that can be transmitted right through their body, and therefore they'll recognize their DNA, and it'll say, that shouldn't be in this body, I'm getting rid of it. So the plasma will remove it out of your body. That's why we're getting so much success with people who came to us in pain, and that's why we're now working with people with arthritis, and we'll have some news for you next week on repairing several people's arthritis on the knee, elbows.
Awesome. Dave, let me hold these up a second. These are, am I showing up on the screen, you guys? These are different pads that Heather sent me, and they're just amazing. Each one is different. I have a seawater GANS and COO, CO2, fruit GANS, all these, and she's put like a fabric in each one and cut it. So it makes a really beautiful sealed packet with a label on it. And then these have literally been helping me get rid of a skin condition on my back. It's awesome. I'm very stoked.
I really appreciate Heather's work. I've been watching her for some time now. We don't communicate too much, but I'm sure that might change. But she does some really good stuff. I so appreciate how she goes about making those cannons as well. They're really beautiful.
Yeah,
So,
and we're all kind of learning from each other.
we are, aren't we? Yeah.
How about you and Daniel showing us what you did earlier with the blow dryer and plug in, just being able to plug in, and then we'll come back. Or should we just go to your setup first?
Okay, we'll take you for a walk. Don't get too dizzy when I move
Yeah,
this.
don't get too dizzy.
So I'm going to move this. We've got a nice extension.
Let Daniel show us the plug.
Okay, so Daniel, okay, now I'm going to be showing you here.
Okay, slow down, you guys. Dave, hold that camera really, really slow.
Yeah.
It's a 220 plug. And we're going to plug it in here along with these other devices that are also running at 220. Can you see that? That's right. 220 volts. And now we're going to put in a 110 2000 hair dryer as well. Can you see that working here? Going into the same bank of plug. So they're both plugged into the same. They're both plugged into the same extension.
Nice. That's awesome. So you plugged a 220 and a 110 into the Magrav unit and ran them off of it. That's really cool.
What we're looking at, Kerry, is a not electricity, but plasma emulating electron vibration. So if that was electricity, what would happen would be spectacular. and I'm not sure I'd still be here, you know, so that's the way those things go. So essentially, this is proving that the basis of this plasma technology is sound, it's real, it's time I sat down, yes. So the thing is, essentially, we're looking at the reality here. You know, what is going to be paradigm changing for the world. So,
Well, I'm absolutely delighted to be able to introduce you today to Hector Gomez. He's the owner of this building. He's the owner of the t-shirt company and all the machines that made this. Hector, ¿habla inglés? No? No.
Hola, Hector. ¿Cómo estás?
Bien, gracias. ¿Cómo estamos?
Okay, so he's going to be our marketing manager and advertising manager. And boy, he does a good job. So I'm absolutely delighted to introduce him to you because we've not met him before on these shows. And he's literally the intelligence behind Keshe Foundation Peru, okay?
Bueno, bueno.
Bien, gracias.
Mucho gusto.
De igual manera, también un gusto.
Yes. Okay.
Now, another thing that I'd like to point out that today happened was this. Okay, thank you, Hector. Gracias. One of the things that happened today was we went over to the mechanics right over the road here where we've got our cold ice coconuts. He's also got a mechanic shop. He's very, very interested. He's sending a lot of people over with illnesses that we can cure. Not cure, it's what's the word we use, Carrie?
Just offer them the treatment and allow them to achieve greater wellness.
They become well themselves because once they've got the confidence of using these, they cure themselves. It's nothing to do with us. We've just given them the facility. Now, what's very interesting was 2 car engineers, if there's such a thing, that work on these motor taxis here, which we've got 46,000 in Tarapoto. They are going to be getting a donation from us of the first type of machine, shall we say power reactor, that's going to run these motor taxis. We're going to be giving them, and these 4 engineers, Peruvian engineers, 2 are electrical, 2 are mechanical. I'm going to give them the machine the same as I did for Carlos in the shop, and they can connect it to a car and see how that's done. And if John Carl has got the blueprint for that, if he can let us have it, I'll convert it into Spanish.
Yeah, that is so exciting. And what I wanted to say is, Dave, I remember when you first went to Tarapoto a couple of years ago, and the dream was talked about to help the all those motor taxis to move away from gasoline, because there's a lot of pollution from it. 46,000 of them. That's amazing. And there are these little motor taxis, and it's a great way for transportation. But if we can start switching those over to plasma energy, oh my gosh, what a great, cool thing that's going to be.
Well, if we get these mechanics and electrical engineers who work on car electrics, the specific job, and if we just convert them over to plasma, John, this can be done, can't it?
Yeah, JC, go ahead. Show us what's happening.
Well, I should go into a little bit of history here. With the typical car unit, the Magrav car unit, we have 3 layers of coils such as these, and they're connected together, and you hook that up, one side to positive, one side to negative, and it infuses your system with the plasma energy. We found that we had a number of failures in that certain components, if they happen to fail, they get bashed while they're shipping. They weren't assembled correctly. There's a number of different things that can go wrong. Then you wind up with a dead short across your battery, and it drains your battery, and your car doesn't work anymore. So the Innovation Center in the Philippines has been working on this, and what they've come up with is to take the 3-stacker apart and simply use 1 layer on each side of your battery. Now, the counterintuitive...
JC, that 1 layer would be 2 inner coils, 1 inside of each other, and 2 outer coils, 1 inside of each other, right? The
Yes.
entire 4-coil.
Yes.
I don't know. Is that
It
how?
would be one layer of that stacker system.
Want to hold it up one more time?
I'll switch my other camera here.
Okay. Just so, yeah, Dave, we can't see you.
Okay, this would be 1 layer. Okay, this would have GANS paste in it, and the coils themselves would have a GANS coating on them. Okay, this one isn't complete. This is just for demonstration purposes. But it's you take the complete assembly, which is there's 2 coils here. There's 2 coils here, one inside the other, and then these 2, one inside the other. They're wired together in a very specific way with the GANS coating. You wind up with a plasma potential on your 2 output wires. Now, what we're finding, what the Innovation Center has found, is that we only need to use 1 of these wires. On this system, this would be your, let me see, this would be your positive wire, so that would go to the negative of your battery, and this wire would just be left. You wouldn't connect it to anything. On the other, you would have another set of coils, which you would hook up the other way. This one would go to the positive of your battery. This one would be left just loose, and they work just fine that way. Now, it makes absolutely no sense when you look at it from an electrical point of view, but the Innovation Center has found that this does work, and this will eliminate the problem that we're having with the system shorting out. There's no capacitors involved. It's just simply the 2 coils. Now, while I was discussing this with them this morning, we can use little tiny ones. This is the same.
Wow, serious?
That is the same configuration as the larger coils. It's the same number of turns, the same fits. They're built exactly the same way. They're just made with a very, very small wire. This will work just fine.
Oh my gosh, that is my speed.
I've got an electric 72 volt. I've got a 72 volt electric motorcycle coming, and that's what I'm building this system for, is to add this to that electric motorcycle and use it as well as a test bed. We've had issues with purely electric vehicles, and the original car Magrav doesn't work properly on a purely electric vehicle. They work really good on internal combustion engines, provided everything inside that unit is perfect. With the purely electric vehicles, we can use the single coil stacker or the single layer, this system on a purely electric vehicle. We can have one set of coils on the high voltage battery, on the positive side of the high voltage battery, which is the negative is all ground. So there's really only one side there you have to worry about. And then we can take two more and put them on the low voltage battery and get the plasma benefit on both high and low voltage systems of an electric car. We're testing this right now. We've got a system being installed at this moment on a RAV4 EV. And so we will have data. It's going to take probably, I would think, probably a month to get really meaningful data from this. But we're very confident that this is going to work exactly the way we expect it to. There's a couple other things you can do with an internal combustion engine. You can take a small piece of nano-coated wire. This is just, for example, this is not how it's done. I haven't designed the actual shape of the coil yet. But you take a small coil, doesn't have to be much bigger than this, and you nano-coat it, and you put it between your spark plug and your plug lead on all of your cylinders. And this infuses plasma energy into the combustion system of your car, and you will have almost immediate effect. You should notice much smoother running, a little bit more power, cleaner emissions, all of that sort of thing. Now, Kerry, you mentioned before, yes, there's 47,000 of these little, I think half of them are two-stroke, or most of them are two-stroke. These little motorcycles, because they're a motorcycle with two seats on the back.
Kind of like tuk-tuks.
Yeah, very much like that.
Yeah.
And it's not what the system, the way it's right now, the way the system is right now, it's not going to take them off of fossil fuels, but it should make them significantly more efficient and reduce the emissions. And that's what we're expecting to see when we install these systems.
JC, I have a question. So if a person is wanting to build these 4 coils and they want to understand how to properly make the connections from all the coils, is that now in the blueprint that can be downloaded free at the Keshe site? Is that what you would, keshefoundation.org, is that where they would find the diagram on how to wire those properly?
The connection for a single layer of the stacker is exactly the same in the house unit, the car unit, and in the single coil. It's so the connection is identical.
So that's in the blueprint for the Magrav unit, right?
Yes.
Okay. So
it's a little bit confusing at first when you first look at it, but once you see how the flow goes, then it'll get clearer. You just have to study the drawing and you know, follow the wires and follow the connections, and then it makes a lot of sense. Dave,
do you think we could do a video on that sometime?
Sorry?
Do you think we could do a video on that sometime?
I do have a set of coils that I haven't wired up yet. We can, I think we can do a video on that. We've got a new connection system coming out, which Dave is working with. He's working primarily with the capacitors, but he's moving also into wiring the coil layers together with this system. And it doesn't involve twisting wires together. It's a series of just little, let me see, smaller coils like this that you can just plug a wire into.
Wow.
You plug one into one side, one into the other side, and you're done. You don't have to, there's no twisting wires. You don't have to worry about any of that stuff.
Well, maybe we can do a special video that shows some of these things. Man, those little coils are like so exciting. I can't even tell you. I'm like ready to jump up and down. And are those, what gauge wire did you make those with?
I don't know the number. I think it's 28. This is from Ethernet cable.
Oh.
The same stuff you plug into your router and your modem. If you take it apart, you'll find 8 wires, and that's what this wire is I've taken that apart. And one pair takes about 30 feet with the size of mandrels that I'm using. And
Wow.
the mandrels are just simply steel rod.
Right.
Nothing special. I use 1/8 and 3/16 rod. Those sizes, they're not set in stone. What you want is a nice tight fit, or a close fit, I should say. This is the 1/8, and that's the 3/16. And do I have one that I can assemble here? I'll just straighten that out a little bit so it'll go through. And the idea is you want the inner coil to fit really, really nicely into that outer coil. So it's a nice, tight, close fit. Not a snug fit, but just a nice, close fit. And the numbers are the same, 81, 144. I had thought last night about making one that's twice that size and one that's 3 times that size. So instead of 81, it would be 162. And instead of 144, it'd be 288.
And when you talk that, we're talking coils, 81.
The number of turns in the coil. Okay. The way I do mine is I know the diameter of my wire. So what I'll do is, okay, this is 20 thousandths of an inch wire. So I'll take my calipers, and 81 times 0.02 is 1.62. So 1.62 inches, lock that up, and that's, if it was not on the mandrel, what I can do is just press the calipers into that, which will stretch that coil, and I'll know I have 88 turns or 81 turns there. It goes so much faster than sitting down with a toothpick and counting all your turns. And I think
Cool.
If you're out 1 or 2 turns, I don't believe it matters.
Okay, I think we should, those are a lot of details. Let's pass it back to Dave. And Dave, before you go into capacitors, what? What, JC?
Oh, just pass it over to Dave.
Oh,
He's over
cute.
on the screen.
Yeah, thank you so much. So that's a fantastic explanation. And let's do a video sometime soon on hooking those coils together in a little more detail, because I know you can go into a lot of micro detail, but it'd be good for people that want to learn. And thank you.
Yeah, a lot of people have had trouble with the mechanics of this. Not so much the concepts behind it, because you don't really need serious detail within the concepts. But to create a system, there's a couple of mechanical things that you need to take into account. And a lot of people, they just don't have the experience. And I love teaching people how to do this, because it's so cool watching them going, I've never done this before, but I did it. They get so excited. It's great.
Awesome. So Dave, if you're going to talk about capacitors, are you giggling over there? If you're going to talk about capacitors, please explain to us first what they are, okay? Hola.
Well, let's take a practical look at what arrangement we've come up with. That is one, if I show that for you, a complete arrangement that can be disassembled. This is the problem that we've been having, the bit of history that we've been having is when you twist your capacitors together, it looks something like that mess at the front there. Now, we've smartened that and made very professional version now, where we've got boxes and boxes of these connectors, and these are really cool. Let me show you that. And once you've made a bunch of these, we make a second type, which is a one of these, which is half. Let's show you this, very important. Half for 2 wires to go in, and the other 9. So you got 9 turns there for 2 wires to go in, and 9 turns there for 1 wire to go in. And then everything else is in kit form. We can draw up, John possibly could draw a schematic for that, because when you join that on there to the machine, you've got the input. These connect using these professional wires. Everything else can be drawn up. That's 4 inches by 6 inches piece of wood. So therefore, these, we make individual ones. Let me show you this, Kerry.
And so those are capacitors for a Magrav unit. And what does that mean? What is a capacitor, if you can tell us?
John's going to give us a better description than I can give you. So let's go back to John.
Well, the capacitors for the home unit, they help smooth the energy that's coming out. It makes it a little bit smoother. That's all I can describe it as. The original car design, we had to put a capacitor in line as a DC energy filter. So the electricity couldn't just pass from one side to the other and drain your battery. But now that we're going into a different configuration for the cars, the capacitors in the car units are no longer required. If you imagine the energy that's coming out, if you look at it on a graph, it's kind of spiky and jumping up and down a little bit. When you add a capacitor, it smooths that out and makes it a little more consistent over time. Now, that's a really lousy description. I understand there's people out there that could probably explain it a lot better than I can, but I can't think of the right words that most people would understand. In typical electrical terms, if you have a capacitor in line with your electrical flow, only certain frequencies of AC will pass through. DC will be blocked. If you have it across the wires, then your AC is going to be blocked and your DC will go through. Now, that doesn't necessarily mean this is what's happening with the Magrav system, because we're dealing with plasma, and that's a whole different animal. But a very similar sort of thing is happening. And we're using it to as a slight booster. Because it'll store a little bit of plasma energy and release it when the energy drops. That's how it levels everything out a little bit.
Oh, that's a nice explanation. I like that. Very cool.
Okay.
Awesome. Dave, onward.
Well, what is interesting about this little arrangement that we've got here, the problem is the pins. Now, I'm showing you this for a reason, because that is, you've got to make that when it's been nano-coated. And what's been happening is we've been having problems joining these cables and breaking the nano-coating, and therefore they'll show sparks when you plug them in. So what we've come up with is this new system whereby you just make these. And that is one side, and that can be all stripped apart, put it into your nano-coating, get 3 days of nano-coating, or even put it in the sun. But also you have another sector, which is that sector. And that can be completely nano-coated, and it can be built beforehand. This is what we're finding, that we can now nano-coat those all in one, and I can do a big mass of them. And then you have all the separate sections. It looks something like this. That's all the pre-made sections. You just nano-coat those, join them together by pressing them in with your pliers, and that should not break the nano-coating. That's the big problem we've all been having. Even in Germany, they've been having that as a problem. So I think we've got a resolve here, and the resolve is that you can mass produce these now, and there's 150 of those jointers. I just sit outside and just make them. And
Dave, for people who are more technical, you know, they might just pick this up really easily, and maybe we'll do a video with you sometime and just go through all the steps of making them so other people can learn.
Well, my question is to John Carl is, can you draw that up? Because, oops, can you draw that up? Because that goes into two sections. One goes into the other, and then you have to put the papers on. Let me show you this one again. You put your papers on there, which have got the GANS on it. These aren't particularly good example because the GANS didn't turn out, but I've got quite a good system of painting the GANS on. and then hang it out on the roof to dry, and then you fit them, and they fit snug into that. You just literally use your patience. They're bouncing all over the place here, but they fit together, and you make 2 sets for each machine of 3. And basically, let me show you again. I've changed. Another update is that I've taken that joint out of there. We don't need it, so I just go into a 2-part. I'm going to separate it for you now because it's quite tight. There you go. And how you put it together is you get that one aligned with that one. There, let me show you. You get that one aligned with that one. Then you get your double, and you literally insert it in through there. Very tight, very, very tight. There you go. That's how that works. And that's the same, but with a small piece of copper. So and all of these can be pre-made now. All these can be pre-made. They've got the turn loops there. That's the ones that hold the paper that go in the center. And you can make the other one. All these, we've got a drawing somewhere, Daniel, haven't we?
Yeah.
So we recorded it, and we want to make that an official drawing. There's all your sizes there, and all your parts to make and mass produce these things. So, Carl, can you draw that up for us?
Yeah, I can. As soon as you scan and send me the files, so I have the numbers you've got, then I can do an official drawing. It came up while you were discussing that. I want to clarify this question before it even arises. And Mr. Keshe has mentioned that not to worry so much about the nano-coating because it will correct itself. This is true after the system is running for a while. When you first plug the system in, your nano-coating and your connections need to be perfect. If there's cracks, if there's crushed, if the coating is scratched, you're going to have problems. Once it's running for a while, if you can get away with it and not have sparks, then it will correct itself. But it's the initial, when you first plug the thing in, if there's a flaw in your coating, you're going to have problems. And that's why we're coming up with this plug type system. What I'm going to draw up, Dave, I've been looking at this and thinking about this for a while, and I'd like to get away from the 2 into 1 if possible. And I think I have a way of being able to do that so that you don't have any of these butt type connections. You've got one running through with a coil around it and another coil over here, which is your second capacitor. Those coils are part of that capacitor. So you would have the one capacitor on the end with a really long lead, and you just slip one in, and then slip the second one in, turn the end, which would be even simpler system than what you've got here. And I think it's going to wind up being a little more reliable. But in another 2 weeks, we'll probably have somebody else that comes up with something even more innovative that's going to work even better. So we're constantly learning. We're always looking for input. If anybody has any ideas or suggestions for this, please bring them up, because that's how we learn. That's how we improve this. That's why we're open sourcing this, is so that we can get as many minds working on these things as we can.
Mm-hmm.
Excellent, you guys. That is totally awesome. A lot of innovation going on here, and a lot of innovation to contribute to this global pool of what we're doing and learning and growing in. So a lot of detail there, and I think those who are already doing it will be able to pick up some really good things. And Dave, let's just do a quick review of the things that you are going to write an XI4 blog post on, and people will be able to connect with you to support the children's program, to support the various modules that you've got coming forward in your center there that's going to be moving towards being a Keshe production center. Also talking about the training that you'll be doing for Thailand and Egypt, that people will potentially be able to order that training from you, and so that they can literally go through the steps of making the Magrav unit at home. And go ahead, give us an overview of what kind of things you're really wanting people to know about and be able to connect with to help you get accomplished here?
Yeah, we're fortunate to know a couple of engineers from Egypt and Thailand who are running health centers, and they are very, very interested in setting up Keshe Foundation Egypt. And what we've decided to do with them is, instead of sending them engineers to Peru, we're going to do an 8-session course of programs whereby we start right through. It's written on the site at xi4.com. You can see the 8 sessions very clearly, starting with the nano-coating, because you can't make plasma, so they need to start making plasma on the earlier sessions so that we can go in and later on start showing you how to make these and smaller ones for the car. With us having 2 engineers here that are electromechanic engineers for cars specifically, and we've got 2 mechanics here, we will be making, in the next 4 days, we'll make what John's been talking about, and we'll have one working here as well. And people can come and learn how to build these things here. That's what I would like to see more people come to the Keshe Foundation Peru. Now that we've been recognized, which I'm absolutely delighted to inform you that. So basically the offer of coming here, paying us the $500, you walk away with a machine. It's working. You walk away with pain bags. You walk away knowing all about the health sector of the Keshe works. You also know exactly why you're making your machine and how, and you then get to understand how the plasma works and how these machines work in cars and in houses. That's a pretty good deal, Kerry, and I'd like to see more people coming to see us here in Peru. Literally, I've got the confirmation that Eduardo's machine that he built here is now switched on and running in his house. This is a man who built 4 machines and couldn't get them to work. So coming to Keshe Foundation Peru has really turned his life over, and that's what I'd like to get the message across. We have got that power. We can turn your life over. And we've also heard that Wan Chang from China, his machine is now working, so we'll be getting progressional reports from him, and we will show our machine and we'll show our electric bills, because our machine is now working and running the office, and we're going to be doing some more alterations to that so that we can run more power in this office and we can get it right up to maximum. So keep an eye out for these courses, because you might be able to just pay for a course, and we're going to put it together that you can either teach yourself online. John's got a few ideas of how we can put a gateway in on the xi4.com site so that we can get this message across that you can learn everything about this for very little money at all. Finally, I'd like to say that we are in negotiation to make 500,000 of these units for a city in the north of Peru. We're negotiating with the government via a trust company that is working from Ecuador, and I'm going to be in direct contact with them. So there's a lot going on here now, and we're chiefly only dealing with Peru. So if you want a unit from Keshe Peru, you come to Keshe Peru. Okay, Kerry?
Awesome, Dave. That's totally exciting. And JC, thank you. I'll put us back on gallery view here. Thanks so much, you guys. I mean, I think there's so many people in the world that are interested, hungry, ready to take this next step. Daniel, I see you peeking around the wall there. Thank you for your participation. And just many blessings to our listening audience, and we just want to encourage you all to keep thinking about your own possible future, participating any way you can. One of the things I've been talking about with Whitney is starting a kind of a workshop in your neighborhood where other people who are interested, you can all get together in the same garage and work together, or the same space. And again, Dave will be doing trainings that will both be available online, that you'll be able to pay a small amount to be led step by step how to do everything, and maybe even a group of people could co-opt that with each other. Or you can get on a plane and go to Peru. It's an awesome adventure. I love going there. I mean, I've started going every year at this point, and I'll be bringing some people down in November, I think, to see you, Dave. But meanwhile, I want to encourage people to get your own ticket, get over there to Tarapoto, Peru, and hang out with Dave for a week and build your own unit for your house, your car, your health pads, health pens, and take them home, and you've got it done. So I know I'm a lot better when I've got somebody else standing there helping me, you know, who has a skill that I don't have. I think many minds work together in order to bring these things into being. Just trying to struggle through it alone is a little bit difficult. So we're learning together, we're growing together. Thank you for being part of this global community that is aimed towards world peace, abundance, and good things for all of humanity, all creatures, Mother Earth, and may we move forward into a wiser civilization. Thank you all so much. Many blessings, and we shall see you on the next show, and we'll put links below the video so that you can get connected with Dave. All right. Adios.
Thanks.
Thanks from Peru.